Okay, Chiluba and Company is considering forming a portfolio consisting of two stocks, Stock A and Stock B. The finance team has collected the following historical return data for these two stocks. We've been given the years and the returns of the stocks. C&C plans to invest equal weights of the portfolio in Stock A and Stock B. The correlation coefficient between Stock A and Stock B is known to be 0.8. So, this question here we're dealing with returns and risks. So here notice that we don't have any probabilities here. Okay, so we're just going to use the typical methods of finding our average return, which will give us our expected return, and our standard deviation, which is going to give us our risk. Alright. So remember, what does risk tell us in this context, colleagues? We did this topic, so I hope we remember. What does risk tell us? When we're talking about risk here, what are we talking about? Yes, Madam Precious? Okay. Mr. James? Mr. Trywell? Colleagues, you'll be portfolio managers, okay? You'll be handling people's money and investing their money. So, you need to know what this risk is talking about, okay? Because can someone trust you with their money if you do not know what risk is involved? I believe the answer is no. So risk is just how far your actual return is from your expected return. Okay, it's just that diversion or that dispersion of the actual return from the expected return. High risk, it means your actual returns might be very far from your expected returns. The expected return is like it gives you a base, gives you a, how can I say, a benchmark, a point of reference where you expect what you expect your return to be if you invest in a certain company. Okay, so the expected return gives you like a benchmark. Now the risk, you have to know, okay, from this benchmark, how spread out are my actual returns? If your actual returns are very far from your expected return, high risk and predictable. It means the stock is volatile. Okay, it fluctuates a lot. Low standard deviation, low risk, it means your actual returns are close to your expected returns, which represents stability. Okay, so for the expected return, colleagues, we just add up all of these and divide by 5. Okay, so for stock A, we're going to say 20% plus negative 10% plus 5% plus 35% plus 15% divided by 5. When you add all of this, you get 65%. 65% divided by 5, 13%. Stock B, again also you just add these returns and divide by 5. And so negative 15 plus 25 plus 30 plus 20 plus 35, get 95% divided by 5, 19%. Okay, so if you invest in stock A, you expect a return of 13%. If you invest in stock B, you expect a return of 19%. So this is like your benchmark, okay, of what you are to expect. Any questions, colleagues? before we move to the second part. Calculate the deviation for stock B based stock. Stock. We also put an A. Okay, we'll calculate the deviation for stock B and A based on the historical data. So basically, we're calculating the risk. So notice here we're calculating the return and the risk for each stock. Then from part 3 and part 4, we'll now treat it as a portfolio. Okay. Remember, a portfolio is just a group of investments. You are trying to lower the risk, okay, by not putting eggs in one basket. So the deviation for stock B, as I said, just like how we do it in statistics, all right? Since there are no probabilities here, so we use this formula here. The individual return for each stock minus the expected return squared divided by n. Okay. So basically, if we're starting with stock. Okay, well, I started with stock B. So also for stock A I'll get. But if we start with stock B, it means all these returns you're going to subtract each of them with the expected return, then you square. Okay. So this negative, the expected return for stock B was 19%. Okay, so we're going to say negative 15 minus 19%, and you square. Next one, 25% minus 19%, then you square. Next one, 30% minus 19%. And you square this. Next one, 20% minus 19%. And you square. Just like that, colleagues. Alright? As you can see here, subtract each of them with expected return and you square those values. You add, you do your tabulations, you get 17.72%. Okay, for stock B. Okay. Not very high, but it's kind of big, this standard deviation. Not very big though, but yes. Any questions? So think of it like this. For stock B, your benchmark is 19%. Okay, so 90, say 19,
Yes, are you recording?
Yes, I'm recording. So that once you get your notes, you can refer to these videos. I can get you.
I saw another formula that had, is it n minus 1 at the end for standard deviation? I don't know how I saw it.
Oh yeah, that one is when you're using a sample, then you do n minus 1. But when you're using a population, you do it by n. You won't be penalized if you do n minus 1, but here we're treating these returns as the population, or the returns you can get from stock A. Here, talking about here, we put n minus 1. Is that okay, madam? Is that okay?
Yes, sir.
Okay, so as I was explaining, so think of it like this. Your returns can possibly be in this range. They can even go maybe higher or lower. But for stock B, think of your returns in this range from 1.28% to 36.72%. Within this range, that's where your actual returns can be. Okay, also for stock A, I think, where did I calculate for stock A? Since there they put and stock B, so I'll put stock A. So same thing with stock A, each return subtracted from the expected return. Okay, and then you add the numbers up and divide by 5, we get standard deviation of 15.03%. Yes, any questions, queries before we go to part 3, expected return of the portfolio? Okay, number 3, the expected return of the portfolio. So now it's for a portfolio, not a single group, a single thing. Okay, so expected return, it's the weight of stock A multiplied by the expected return of A plus the weight of stock B multiplied by the expected return of stock B. So they told us the that's what I'm calling it. Okay, so they told us that the portfolio is of equal weight, so 50-50, so we just use 0.5. Okay, expected return for stock A 13%, expected return of stock B 19%. Okay, so 0.5 times 13, 6.5. 0.5 times 19, 9.5. So expected return 6.5 plus 9.5, you get 16%. Okay, so if you invest in both stocks, stock A and B, okay, expect a return of 16%. Now, also another thing you need to remember, other times they'll give you money. They'll say, okay, this person invested, let's say, 500 in stock A and 1,000 in stock B. So, do we know how to calculate the weights in case you're given money? If they give you actual figures, just in case he tries to change anything. They say 1,500 was invested in stock A, and let's say 5,000, let's say 10,000 in stock B. So the weight for stock A, 1,500 divided by the total amount that was invested, 15 plus 10 pin, 11.5. You'll get the weight of stock A. The weight of stock B, we say 10,000 over 11,500. Okay, that's in a situation where you've been given amounts of money. You can calculate the weightages like that. And remember this concept because we're going to see it in the thing. Weighted average cost of capital. So just remember, when we say the word weightage, we're just saying what proportion is this representing out of the total proportion. Okay, so there when we used money terms, we're just asking out of that 11,500 we invested, how much was invested in stock A? That's what the weightage is saying. Out of the 11,500 that was invested in stock B, in both stocks, how much, what percentage represents stock B? Yes. So any questions on the portfolio expected return? It's 16%. Okay, calculate the portfolio risk and comment diversification benefits. Alright, so portfolio risk. Now here, colleagues, notice we've been given a correlation coefficient. Okay, so our formula for the portfolio risk is going to be slightly different from the other one that we did last time. Okay, this is the formula for the portfolio risk. Okay, since there's a correlation coefficient here, last time we had the covariance. Okay, we had the covariance. So if there's a correlation coefficient, colleagues, you don't need to calculate the covariance. Okay, because there's a correlation coefficient, so no need to calculate the variance. But if they don't give you a correlation coefficient, okay, remember correlation coefficient is just showing a relationship between two things, stock A and stock B related. Okay, the closer it is to one, the better the relationship. That's what the correlation coefficient just tells us. Okay, so this is the formula for the portfolio risk. Let me put it in simple English. Weightage of stock A multiplied by variance of stock A plus and squared weightage of stock A squared plus weightage of stock B squared plus the variance of stock B plus 2 open brackets 2 multiplied by the weightage of stock A plus weightage of stock B multiplied by correlation coefficient times standard deviation of stock A multiplied by standard deviation of stock B. Okay, colleagues, this is how we are calculating the portfolio of risk or a portfolio standard deviation. Okay. Portfolio you say portfolio variance or risk? So yeah, risk. So we have to get standard deviation. Okay. So after we do this, then we get the square root to get the standard deviation. So we've got all this information here. Weightage of stock A 0.5 squared. The variance of stock A here 226. Weightage of stock B 0.5 squared multiplied by the variance of stock B, we got 314 here. Two multiplied by 0.5 weightage of stock A, 0.5 weightage of stock B times correlation coefficient by standard deviation by standard deviation of stock A and standard deviation of stock B. Okay, once we do all our tabulations, we get 241.48. In the standard deviation, you just get the square root, because remember this formula here, you're just getting the variance. So to get the standard deviation, just get the square root, and you get 15.54%. That is the portfolio standard deviation, which is almost similar to it's near to the individual standard deviations. Yes. Any questions?